Hi everyone, my name is CarolineBertolli and I will be taking you through a spatiotemporal classification of West Coast wine regions using viticultural climate indices. To give you some context, I'll start with a little bit of background information. Geography and wine production have been inextricably linked pretty much from the start. The French developed the term terroir to describe the environmental and human variables that influence crops' phenotypes both inter and intra-vineyard. Terroir is not concretely defined, as shown by the graphics on the right, and can contain any number of variables. Yet it is the basis of the French appellation system used worldwide. This system asserts that wines from specific regions are irreplicable, regardless of identical growing conditions and production methods. While there is debate over the significance of terroir, particularly between Old World and New World industry members, it is true that climate directly affects grape phenology, yield, and wine style. Cooler climates with shorter growing seasons are good for early ripening varieties. These wines are lower in alcohol and higher in acidity. Warmer climates with longer growing seasons are good for late ripening varieties. These wines tend to have higher alcohol and lower acidity. This is important to note, as younger demographics are showing preferences for lower alcohol products, alternatives to wine, or abstaining from alcohol altogether. Grape ripening is driven by temperature that controls the conversion of acids into sugars. The speed of ripening is measured by growing degree days, or GDD, which is calculated using the daily temperature and the base temperature of a crop or pest. GDD is also useful for predicting vine growth stages, timing for fertilizer or pesticide application, and for assessing site suitability or heat stress. The base temperature for grapes is 10 degrees Celsius or 50 degrees Fahrenheit, under which it's assumed that no growth occurs. Different varietals need different amounts of cumulative GDDs for a specific growth stage. The Winkler Index uses cumulative GDDs of the growing season to form a classification scheme of 5 or 6 regions, each with different general ripening capabilities and wine styles. According to Winkler, production level potential increases and wine quality decreases with increasing cumulative GDD. However, each region has specific varietals that achieve their highest quality in said region. This study aims to answer the following questions. How have GDD values changed over the past 25 years in vineyard regions? How have Winkler Index classifications of vineyards shifted over time? What do trends reveal about heat accumulation and viticultural suitability? And are certain regions experiencing threshold transitions into different viticultural classes? These questions will be answered by calculating the annual GDD for vineyard areas from 2000 through 2024 using gridded temperature datasets. It will classify American viticultural areas, or AVAs, by year and track changes in viticultural zone classification. Then it will visualize trends and thresholds crossed in key wine regions to identify areas undergoing significant change. The scope of this project was limited to what data was readily and publicly available and how much of it could be analyzed in the timeframe. A shapefile containing established AVAs was provided by the Alcohol and Tobacco Tax and Trade Bureau. Daily temperature data with a 4-kilometer spatial resolution came from the PRISM Climate Group, and the state boundary layers were obtained from Natural Earth. The 5 following AVAs were selected as study areas for their ability to summarize the West Coast through area, overlap with other AVAs, and consistency of longitude with a range of latitudes. Columbia Valley AVA contains almost every other AVA in Washington state. As with all of the AVAs, many varietals are grown here. However, Columbia Valley is most famous for its Riesling, which grows best in Region 1A and 1B. It has been said that Washington would like to step out of California's shadow when it comes to the Bordeaux varietals, such as Cab Sauv, Cab Franc, and Merlot, which prefer Region 2. Willamette Valley, Oregon contains 10 other AVAs. Extreme weather is rare here. Its cool and mild climate make it ideal for growing Pinot Noir, which is a notoriously fussy grape. The North Coast AVA of California contains 58 sub-AVAs, most recognizably Napa Valley and Sonoma County. While Napa Valley only contributes about 4% of California's wine production, it accounts for about 30% of the state's wine economy. It is very well known for its Cabernet Sauvignon, which likes Winkler Region 2. The Central Coast AVA covers 31 sub-AVAs with a moderate to warm climate. It experiences exaggerated diurnal shifts, which are the difference between daytime and nighttime temperatures. Chardonnay accounts for more than half of the grapes grown in the area, which grows best in regions 1A, 1B, and 2. The South Coast only overlaps 4 other AVAs. It is characterized by warm weather, but areas near the coast take advantage of the cool air coming off of the Pacific Ocean by planting varietals like Chardonnay. Inland areas plant heat-accustomed varieties such as Zinfandel. To analyze the time series of Winkler index values in each study area, the following workflow was implemented. First, the vector data was collected and processed. The shapefiles were reprojected to match the PRISM dataset, and the states and AVAs of interest were extracted and uploaded as assets to Google Earth Engine. The states were used to define the area of interest for the PRISM image collection. A range of dates, a function to calculate GDD, and a function showing the thresholds of the Winkler index were also defined. A loop was created to extract daily PRISM images from the growing season, calculate the GDD of each pixel, and then calculate the cumulative GDD of each year. The cumulative GDD images were exported to be classified and visualized in ArcGIS Pro. The AVA asset was used to create zonal histograms, and the count of pixels in each Winkler index threshold was converted to a percentage of the total. These data were exported to Excel for analysis. Regions 1B and 2 dominated Columbia Valley, showing an inverse relationship until about halfway through the time period, when Region 3 increased significantly at the expense of Region 1B. The give-and-take pattern shifted up a threshold, trading off mostly between Regions 2 and 3 in the second half of the time series. Another thing to note is the spike in cooler regions around 2010 and the spike in warmer regions around 2015. Willamette Valley also shows a strong relationship between two regions that shifts up a threshold in the second half of the time series. Regions 1A and 1B took turns covering most of Willamette Valley up until about 2013, when the pattern became Regions 1B and 2. Again, we can see Region 1A spike in 2010 and Regions 2 and even 3 spike in 2015. In the North Coast, Regions 3 stayed relatively stable across the time series. Regions 1B and 2 have been decreasing overall, whereas 4 and 5 have been increasing. Region 1B and 4 also appear to show the threshold shift we observed in the previous AVAs. In the latter half of the period, the pattern turns from mostly 1B, 2, and 3 to 2, 3, and 4. We also see the same spikes in cooler regions in 2010 and hotter regions in 2015. Patterns in the Central Coast greatly resemble those in the North Coast. Regions 1A, 1B, and 2 show a general downward trend. Region 3 has stayed relatively stable, and regions 4 and 5 show an upward trend. 2010 remains significant, although the effect in 2015 appears less pronounced, especially with the overall increase in values of peaks and valleys in regions 4 and 5 in the second half of the period. Regions 1A and 1B were virtually non-existent in the South Coast, and there was very little of Region 2. Region 3 also showed generally low proportions. However, again, when these regions did spike, it was in 2010 and to a lesser degree 2002. Regions 4 and 5 dominate this area, with Region 5 gradually rising. This animation shows the spatial distributions of Winkler regions in Washington and Oregon over the time period. We can see the range of regions in Columbia Valley, but one thing I find interesting is that heat appears to concentrate along the Columbia River. You can almost draw the shape of it from the pattern of Region 4 in 2015. It's hard to say if a similar phenomenon is occurring near Willamette River, since Willamette Valley AVA generally only contains one or two regions at a time. This animation shows the spatial distributions of Winkler regions in California. Within each AVA, heat accumulates further inland. In fact, during hotter years, a lot of Central Valley exceeds the upper threshold of the Winkler index. The coastal areas studied in this project do not seem to be threatened by exceeding the Winkler index, but this is something to keep an eye on over the next 25 years as GDD values likely continue to increase. The results of this analysis beg the question, what happened in 2010 and 2015? To investigate, I looked at the pattern of El Niño and La Niña events during the period of 2000 to 2024. By calculating the Oceanic Niño Index of each year's growing season, similarities were found to the Winkler Index time series. In 2010, there was a strong La Niña event, and in 2015, there was a strong El Niño event. Some other La Niña years during this period include 2007 and 2022, and another somewhat strong El Niño event occurred in 2023. The results of the visualization also showed significant changes in the Central Valley. Around 2005, the ONI was close to zero, meaning close to normal conditions. 2023 had an El Niño event, and the following year showed a threshold shift in some AVAs in Central Valley. For example, Lodi became entirely Region 5 in 2024, and part of Madera exceeded the upper bounds of the Winkler Index. In conclusion, the short-term variability of Winkler region distributions is more drastic than the long-term trajectory. There's a general upward trend in warmer Winkler regions, and in 25 years, we saw a shift up a threshold in the patterns of each AVA. The geospatial relationship between ENSO and the Winkler Index is worth exploring and presents an opportunity for further research. As we enter the next quarter century, strategies for reducing alcohol by volume are likely to become increasingly necessary, whether in the vineyard or in the cellar, in order to comply with consumer preferences. Some areas may have to consider planting different varietals or resort to outsourcing if the effects of climate change become more effort to mitigate than the product is worth. If this were to happen, there might have to be a paradigm shift with respect to terroir, especially if similar patterns are occurring in Europe. Overall, the shift in Winkler regions across the West Coast present new and worsening challenges for growers and producers. From difficult to predict changes in the timing of growing season stages to changes in the composition of the berries, as well as the threat of dehydration and the dreaded smoke taint, monitoring and forecasting climate patterns is becoming more important than ever. That concludes this presentation, so cheers and support your local wineries. I will now open it up for questions.